Hello students, welcome back. At this point, Light Steps is pretty much complete. I mean, it's fully playable, it's fun, it's challenging. What we're going to do here in this video is add some visual polish to our game. We'll call it game polish. These are going to be systems that don't necessarily change anything about how our game plays, but it's all about how our game looks. And so we're going to focus on three things. First, we're going to create a particle system. So anytime we land on a correct platform, particles will fire out of the right color, sort of like fireworks. Particle systems are just super fun, super engaging, and they make playing the game that much better. So I love to use them. Second, when we complete an entire sequence and we get it right, we'll have an overlay flash effect to indicate that success. So we'll draw that to the screen and then maybe fade it out over time. And then third and finally, anytime we get something wrong in our sequence, not only will we reset the player, but we're also going to take our screen and we'll shake it. We'll move it back and forth to give some visual feedback that, hey, you just did something wrong. So let's head to the computer screen and let's work on these visual game polish systems. So I have lesson 8 game polish open here, our starter file in vscode.dev, and I'm going to minimize that so I can open this file directly in the browser. All right, so let's see what we've got. Anything here? Any visual polish? No. Okay, no particles, no overlays, nothing there. And if I die, no screen shake. So none of our polish is happening right now. So let's dive in and see if we can implement some of these systems. So mission number 1 says we have to adjust the polish system constants. Just like anything else, we are adding some new systems here, visual systems. So we are going to have constants that are going to be like knobs or dials that we can tune in and control how the system looks, plays, or feels. So we have constants for our player and our platforms and our physics, and then our difficulty ramp and our enemies and our focus system. And so now we're going to add some for our visual systems. So our first is going to be our particles. Every time we land on a correct platform and we hit a correct platform, we're going to spawn particles. So how many do we want to create per platform hit? Right now it's set to 1. That's boring. I'm going to make 25 of them. And now our particles are not all going to move at the same speed. They're going to be, some are going to be fast, some are going to be slow. We're going to randomize it. And so I'm going to set a minimum particle speed of 500 and a maximum particle speed of 600 for me. And then our particle is going to have a certain amount of life. How long are they going to exist for? I'll set it for 0.5 seconds, so a half a second. And then their size, I'm going to make their size be 10. So I'll just keep their uniform size, uniform life, and just slightly vary their speed. All right, and then for our next system, our success flash, we're going to create an overlay. How long do we want that overlay to sit on the screen? So when we get our sequence all right, 1 second is a pretty long time for an overlay to sit on a screen. So I'm going to set it to 0.25 seconds, a quarter of a second. That seems a lot better. And then lastly, we are going to shake our screen when we get something incorrect, right? If we get something wrong on our sequence or if we fall and die, we're going to shake our screen. So it says sequence restate shake duration in seconds. So how long is that going to last? We'll do a quarter of a second again. So our shake won't be very quick. And what is its relative strength? So I'm going to set a relative strength of 10. And when we get to writing this, we'll look at how we use that relative strength. The bigger the number, the more the shake. The smaller the number, the less of the shake. All right, so let's scroll down. Any new colors in our color palettes? Nope, nothing there. Any new gameplay variables for us? Let's see. Ooh, we have particles, an array to hold all of the particle objects that we will create. We have a success flash timer seconds that will probably set to like 0.25 and then count it down 0.24, 0.23, 0.22, and when it hits 0, we'll stop showing our success flash. And a screen shake timer, same thing. We'll set it and then we'll count it down 0.2, 0.1, and when it hits 0, we'll stop shaking our screen. So we've sort of seen that structure a handful of times now with these timers. Mission number 1 is complete. Let's head to mission number 2. What visual system are we going to target first? Well, we're not. We're going to actually reset some of our variables here. So when our game restarts, if we start our game or reset our game, if we died and there were like particles on the screen, we don't want those to stay in our next gameplay. So we got to make sure we empty out this system. So we're going to take our particles array and we'll make it empty. So now there's no more particles. And then let's reset those timers. So we had success flash timer seconds. We'll set it to 0. Make sure that that's not triggering. And we'll take screen shake timer seconds and set that to 0. Make sure that that is not triggering. All right, so now we have reset our visual systems. We can move to mission number 3. Mission number 3 finds us in our generate particle data function. So if you remember, when we created, let's see, our enemies, we had generate enemy, spawn enemy, and update enemy. And the exact same thing is going to be here for our particles. We are going to reuse that system. We are going to generate our particle data. We are going to spawn our particles, and we're going to update our particles. So right now, we got to generate our particle data. We're going to take in an index of a platform. What platform do we need to create our particles at? And that platform is going to have like an X and Y property. And so right here, we get our platform, all right? So platforms from our platform index. And then we get our center X value. So it looks like it's the platform's X coordinate, which is the left side, and then we're adding the platform's width times a half. So we're going to add half of the platform's width, which puts us right in the center of our X coordinate. And that's exactly where we want to spawn our particles from, the middle of the platform in the X direction. Well, let's spawn our particles in the middle direction from the Y platform too. So let's do platform dot Y, its Y property, that's its top, and then I'm going to add and go down half the height. So platform dot height times 0.5. I think that will work wonderfully for me. All right, I'm going to need an angle because our particles are going to go firing out at different angles. Sometimes our particles are going to go here, sometimes they'll go here, sometimes they'll go here, sometimes they'll go here, they might go here. And how we determine that is we shoot them at different angles. And so we are going to use random to pick an angle, random, from 0 all the way up to 2 pi. And 2 pi is just a complete rotation of a circle. So we'll pick anywhere, any angle on a circle. And then we got to get our speed. So if you remember, I think we said we were going to randomly select our speed between some min and max value for a particle. So I'm going to use random, and we'll select particle speed min, which is this second one, and then particle speed max, which is this first one. So we'll randomly select from 500 to 600. So they're going to be really close in speed, but slightly different, so it looks cool. And then we return this object. This object represents a particle. It has an XY property, Vx, Vy, life seconds, max life seconds, and color property. All right, so let's now go to mission number 4. We're spawning, we're creating those particles. We've got them generated. And so now it says update our particle system. Update and remove particles over time. Move particles when clean and clean them up when they expire. Well, let's run this right now. Let's see if I get something right. Do I create particles? Nothing. Really? Nothing? Are we serious? Well, let's see what happens. So it says update particles for let I equal particles dot length minus 1, I greater than or equal to 0, I minus minus. So what do we need to do? We are looping through our array backwards. So we're starting at the end of our array. And we do this anytime we want to remove something from our array. We're eventually going to want to remove our particles. So it says particle.x plus equals particle.vx times dt. So this is a movement. We've seen this movement before. This is movement in the x direction. Let's also put our y direction movement. So particle.y plus equals particle.vy. We'll take our vertical velocity and multiply by dt. All right, now I really feel like we should be seeing our particles moving here. We should be getting our particles being created. And I just don't know why they're not yet. Let's just take a look. So if I refresh this page, I land here. Oh, there they are. That was the missing piece. I must have had done something right. Boom. Boom. But they last way too long. Boom. That's cool. But they last way too long, right? So what we need to do is we have to use their life in seconds to change them. So if you look here, we've got this life in seconds, how long they're alive for. It says they should be alive for 0.5 seconds. Well, we're never actually decreasing that. So the last thing we got to do in mission number 4 is lower that lifetime in seconds. So we're going to take the particles property of life seconds, and we're going to subtract by our time interval, minus equals dt. And then if you look here, if our life seconds is less than 0, we're going into our array and we're calling splice. That means remove something from the array, and we're removing the particle that is at position I, that particle that just sort of died. So let's refresh and let's see if we now remove them, and they should only live a lot. There we go. That looks much, much better. Perfect. Okay, so our particle system seems to be working wonderfully here. So now let's move to mission number 5, our next visual system. It finds us in the draw scene function, okay, inside draw scene. So this is going to run every single frame. We're drawing our background, our platform, our enemies, our player, our particles, and then our HUD. And it says, mission number 5, our success flash draw. Draw the success flash when active. Display a full screen overlay based on the timer. So based on our timer. So I guess we should probably ask a question. If our timer for our success screen, this is success flash timer seconds. We're going to see if it is greater than 0. So that means the timer has some time on it. What do we want to do? Well, we want to draw something in relation to our success. So let's look at our functions that we have. We have draw focus bar, draw ramp readout. Oh, we have draw success flash. We probably should call this function, and it's got to get written. So let's call draw success flash here on mission number 5. So if our success flash timer is greater than or equal to or greater than 0, let's draw success flash. We'll call that overlay. And now mission 6 has us go write it. So let's go to mission number 6 here. So we'll draw the success flash overlay. Fade the flash based on the remaining amount of time duration. Okay, so let's figure out how we are going to do this. Well, we first call no stroke. And so we're going to get an invisible marker so you can't see the outline of the shape that I'm going to make. And then I'm going to just put some paint in my paint bucket. And I can just put any color I want. I'm going to do 255, 255, 255. I'm just going to pick white. So I'll define that as RGB. So 0 to 255. 255 is all of the value. And then I'm going to draw a rectangle. And the rectangle is going to start at 0, 0. And it's going to take the whole width of my screen and the whole height of my screen. So this is going to be a big white overlay. Let's take a look. All right. Whoa, there it is. I get it right. Whoa, there it was. All right. So it's working, but boy, it's blinding. I don't like that at all. So what I want to do is I want to add some transparency. I want to actually fade this over time. So I can set a transparency here. I don't know. Maybe if I make it like 50. So this is the RGB, and now my alpha channel, when I define a color this way, is going to be between 0 and 255. So if I refresh this now, that looks a little bit better. Yeah, that looks a lot better. So what I want to do is I actually want to fade this. So I'm going to make a variable. I'll call it const flash alpha. And I'm going to set its biggest amount to be 140. We'll say 140. And then I'm going to multiply by a fraction that is going to get smaller and smaller and smaller. And I will use success flash timer seconds over our success flash duration seconds. So when we set our timer, these things are both going to be equal, 0.25, and this is going to be 0.25. Dividing 0.25 by 0.25, I get 1, and my flash alpha is 140. But then as this decreases, right, so it was 0.25, let's say it gets to be like 0.2. 0.2 divided by 0.25 is 0.8 times 140. Now my alpha is 112. So the alpha is going to decrease and become more and more and more transparent. So in here, let's actually use our variable flash alpha. And now we should get a really nice feature for our overlay. And I like how it's triggering here at the start of our game. I sort of like that. It gives like a nice overlay look, and then it flashes to begin. So that's super cool. All right, so we got that. That looked good. That was the exact sort of visual feedback I needed to know that I got something correct. All right, so this is, oh, that little bugger of an enemy. All right. So that system is working great. So now let's go back and let's look at mission number 7. I think the last system we need is our screen shaking. So number 7 says calculate the screen shake intensity. So this finds us in our draw scene again. if our screen shake timer seconds is greater than 0, meaning we've triggered a screen shake, we got to trigger a screen shake, we are going to calculate our intensity and scale the strength based on our remaining duration. So I have two variables here, shake percent and current shake. All right, so shake percent. We're going to take our timer, so screen shake timer seconds, and I'm going to divide it by our sequence restart shake duration seconds. So this is 0.25 and our timer. So again, just like we did before with our timers, when I start the screen shake, this timer is going to be 0.25. 0.25 divided by 0.25 is 1. So we're going to get a percentage of 1, all of it. But as this goes down, as we decrease our timer, let's just say we're now running at like 0.18 seconds divided by 0.25. So now our percent, we're only going to get like 72% of our percent here. And so for our current shake, how are we going to get the current shake value? We're going to take our sequence restart, and then we're going to use the second one here, shake strength, which is 10. That's the magnitude of how much we want to shake our screen. And I'm going to multiply it by our shake percent, because we're not going to shake it at the same strength every time. We're going to start really strong. We're going to start really strong, and then it's going to get less and less and less. The shake is going to die out. And this is going to help us kill off the shake, because our shake percent is going to get lower and lower and lower, reducing our shake strength here. So now what we need to do is we got to figure out how much we're actually going to shake the screen. So I'm going to shake it in the X direction. So I'm going to create a variable. If we look here, we have defined shake X and shake Y, and we set them to 0. So this is going to control how much we shake in the X direction. So shake X, we're going to update it. It's going to be random from negative current shake. So that would be shaking it to the left, to current shake. That would be shaking it to the right. And we'll do something similar in the Y direction for shake Y. Is going to equal random negative current shake. That would be shaking up, and positive current shake. That would be shaking down. All right. So let's see. This looks great. So now we have our screen shake calculation. It's done. We just have to implement it. I don't think it's implemented yet. And so if I scroll down just a little bit, we get mission number 8, our screen shake effect. So we are going to apply the screen shake effect to the camera, and we're going to offset the scene based on our shake intensity. So if you look here, we got something new. It's called the push function. And then all the way down here, we got something new called the pop function. Essentially, it allows us to take our drawing and our canvas and only apply sort of visual effects to what is in between the push and the pop. And we only want to apply the visual effects that we are going to do to our background, our player, our enemies, our particles, and our player. I don't want to do it to the HUD. So I want to shake everything in the game world. I don't want to shake the HUD. And so that's why we use push and pop. Essentially, we're going to say we are only going to put these visual effects on these things that are in between push and pop. So what is that visual effect? Well, I want to move my camera. I want to move this stuff. And to move something, we use the translate function. You just got to specify how much you want to move it by in the X direction. So ours is going to be shake X. And how much you want to move it in the Y direction. Ours is going to be shake Y. And with that, I believe our shake system is done. Let's test it really quick. Ooh, there's that nice little shake. I get it right. I don't get a shake. I get it wrong. I get a shake. I fall off the edge, I get a shake. All right, so that looks really great. Hey, I think our game is pretty much complete. Before we give it our final playtest, let's get rid of our ramp readout because we no longer need it because we're not debugging our game. So let's go down a little bit more to draw HUD. And that's where we're calling our ramp readout. I am almost certain. So inside of draw HUD, right here, inside of that draw HUD function, let's just comment out draw ramp readout. We no longer need that there. And with that, light steps is officially complete. Let's test it. Let's play it out. So here we go. Light steps, a memory path awaits. Cross the light bridges and follow the pattern. Press enter to begin. All right, I start with yellow. Boom. I get that those nice particles, that nice overlay showing success. Loving it. All right, yellow, blue, cyan. We got an enemy now, yellow, blue, cyan. Perfect. All right, my focus is draining as I'm going through to do this, but I get a little bit back every time I land on a platform. Awesome. Yellow, blue, cyan, red. All right, yellow, blue, red. Nope, that was not it. Oh, crud. Yellow, blue. I'm going to spend some focus. Cyan. All right, yellow, blue, cyan. Now it's red. And now I have no idea what's next. Back to blue. Okay. Whew, I just got there. Whew, that was close. Okay. I'm not paying attention. Yellow. Oh, I just rammed into that enemy repeated. Yellow. Blue. Cyan. I know red's next. Jump over him. Yellow. What? That was not right? Oh, no. Oh, no. Okay, we start with yellow. I shouldn't have done that. Yellow, blue. Quick. Yellow, blue, cyan. I thought it was red. Oh, no. I have to start over. I lost the game. That was pretty fun. I got 6 steps in the sequence. That's not bad. I'll take 6 steps. I think 6 is pretty respectable. And if it's not respectable, what certainly is respectable is that we took a broken game in lesson 1 that was, I don't even think it was playable. There was like no gameplay at all. And through 8 lessons, we got to this point here with light steps. This is a fully functioning game with really cool effects, great systems that are all working together. This is a very complicated game. This has got platforming, it's got memory, it's got enemies, it's got resources, it's got visual feedback, all lumped into one game product. So you should be really proud of all of the work that you did here making this game. And I'll see you in our next video.